In our upcoming lectures, we shall delve into advanced topics such as placeholders, variables, and control flow operations, empowering us to build more sophisticated models and tackle real-world challenges. In TensorFlow, tensors flow through computation graphs, propagating data from one operation to another. The flow of tensors is what drives the computation and enables the execution of complex computations. Let us explore this process in more detail. Tensor creation. Tensors are the fundamental data structures in TensorFlow. They can be seen as multi-dimensional arrays or matrices that hold data. Tensors flow through the graph carrying the values of intermediate results or inputs to operations. Tensor operations. TensorFlow provides a rich set of operations to manipulate tensors. These operations take tensors as inputs, perform computations, and produce tensors as outputs. Operations can represent mathematical operations, data transformations, or even model layers. When an operation is executed, it receives tensors as inputs and produces tensors as outputs, allowing the flow of data through the graph. Dependencies and data flow. Computation graphs enforce dependencies between operations, ensuring that the graph executes in the correct order. Each operation explicitly specifies its inputs and outputs, creating a directed flow of tensors. When an operation requires the output of another operation as an input, TensorFlow automatically manages these dependencies, guaranteeing the correct execution order. Lazy evaluation. TensorFlow follows a principle called lazy evaluation. This means that the execution of operations is deferred until necessary. When we define a computation graph, TensorFlow builds the graph structure, but the actual computations are performed only when we run the graph within a session. This lazy evaluation allows TensorFlow to optimize the execution and resource utilization, as it selectively computes only the necessary parts of the graph. By flowing tensors through computation graphs, TensorFlow achieves efficient and optimized execution of complex computations. The flow of tensors carries information, intermediate results, and gradients, enabling us to build and train powerful models with ease. In this example, we define tensors A and B using tf.constant. We then perform tensor operations tf.added, tf.multiply, and tf.subtract to obtain the final tensor E. When we run the graph within a session using ses.runE, TensorFlow automatically flows the tensors through the operations, computes the result, and returns it. Understanding the flow of tensors is crucial for building complex models and effectively utilizing TensorFlow's computational capabilities. As we progress in our lectures, we shall explore advanced techniques such as data pipelines, feeding data to placeholders, and handling dynamic graphs. So, my dedicated learners, let us eagerly anticipate the next part of our TensorFlow odyssey. Until then, may your tensors flow smoothly, your computations be efficient, and your models shine brightly in the realm of artificial intelligence. Nodes as operations. In a TensorFlow computation graph, nodes represent operations or computations. These operations define the mathematical transformations or manipulations that are applied to tensors. Each node in the graph corresponds to a specific operation that takes input tensors and produces output tensors. TensorFlow provides a rich library of operations ranging from basic mathematical operations to advanced deep learning layers and optimization algorithms. Edges as tensor objects. In the context of computation graphs, edges represent the flow of data between nodes. Specifically, edges are tensor objects that carry the data from one operation to another. Tensors are the fundamental data structures in TensorFlow, and they encapsulate the values or intermediate results generated by operations. These tensors flow along the edges, connecting nodes and enabling the seamless propagation of data through the graph. In this example, the computation graph consists of multiple nodes representing operations. The tf.add, tf.multiply, and tf.subtract operations are nodes that perform addition, multiplication, and subtraction respectively. These nodes are connected by edges, which are tensor objects, A, B, C, D, carrying the values between operations. By understanding the interplay between nodes and edges, we can visualize and comprehend the flow of data through the computation graph. This understanding is crucial for designing and debugging complex models, as it allows us to trace the path of tensors and identify potential issues or optimization opportunities. In our future lectures, we shall explore advanced concepts such as control flow operations, model layers, and graph transformations, empowering us to construct sophisticated models and push the boundaries of AI research.